In this lab, we will go through a series of copper reactions. This lab is designed to demonstrate the principle of the law of conservation of matter. Remember that the law of conservation of matter says that matter cannot be created nor destroyed. So as we go through the series of 5 reactions, we'll start with copper, produce copper 2 nitrate, then produce copper 2 hydroxide, then produce copper 2 oxide, turn it back to copper 2 sulfate, and then we will finally end back with copper. Some terms you will be dealing with in this lab include boiling chips, which are small irregularly shaped stones added to liquids to make them boil more smoothly. The term decant means to pour off. Precipitate is a solid formed when you mix 2 liquids together. Supernatant, the clear liquid above a sediment or precipitate. As you work through the lab, stop after every reaction and fill out the data sheet.
The first thing it tells us to do in this lab is to get some water boiling. So what I did is I measured out 200 milliliters, or about 200 milliliters of distilled water. We're going to light it. We're going to get it boiling for the third reaction. So the first step in the lab, it says to weigh out between 0.5 and 0.55 grams of copper. So we're going to be using copper powder. It's like this. And so we tarred out our balance, and we're going to keep putting the copper powder. It's probably easier to sprinkle just a little bit. Okay, that's really close to 0.5, 0.55. Let me see if I can get another little scoop of it. Okay, so we're going to go with 0.59 grams of copper powder. So you need to make sure you record this in your data sheet. Okay, so the next portion of the lab says that we're going to add 4 milliliters of nitric acid to our copper. So as you watch this, you're going to see a brown gas evolved. I'm going to add it all at once. And so we continue this until all the brown gas has evolved. Once the brown gas has stopped evolving, we're going to add 125 milliliters of distilled water. So I'm going to go back to the tabletop. And I've already pre-measured out my water. Okay, so got 25 here. And we got 100 right here. So note the color. It looks like that. And we'll proceed to the next reaction. Okay, so after every reaction that we record in the lab, we're going to go through the data sheet, especially the chemical reactions, because some of these are kind of difficult to balance, so we're going to go through that really quick. Okay, so we're going to go through the reaction. We got copper plus nitric acid is HNO3. And it says we're going to produce copper nitrate. And we get that from our crisscross, like that. Plus NO2. That's the brown gas given off. And water. Okay, so this one's really tricky to balance, so I'm just going to balance it for you. There's a 4 right here, a 2 here, and a 2 also right here. This is the only one I'm really going to balance for you because the rest are pretty easy. There's 2 nitrogens here, plus 2 nitrogens here, so that's 4 total. So you got to have 4 total nitrogens, 4 hydrogens, 4 hydrogens, 12 oxygens total. You got 6 here, 4 here, that's 10, plus 2 is 12. Okay, what makes this tricky to balance is this NO3 kind of shows up in 2 spots. It shows up right here, and then it goes to an NO2. Okay, so that's how you balance this reaction. Reaction number 1. Okay, so we have our copper 2 nitrate, and it says we're going to add 15 milliliters of sodium hydroxide to our copper 2 nitrate solution dropwise. So I'm going to start off doing some drops. and let's notice what's happening. Okay, so it looks like it's forming some sort of gelatin substance. Okay, so I'm just adding dropwise, and I'm going to keep doing this until I've added all 15 milliliters of sodium hydroxide. So let's just kind of slowly add this in. And I like to think that this looks like flubber. Okay, so you see you got solid copper 2 hydroxide that kind of formed as a precipitate. So we're going to go to our data table and we're going to look at the preparation of copper 2 hydroxide from copper 2 nitrate. So this is reaction number 2. What color is the copper 2 hydroxide solution that is produced in reaction 2? You can get that from the video. And now we're going to write and balance the chemical equation for this. Okay. So it says copper 2 nitrate okay, we get that from the crisscross. Reacts with sodium hydroxide. So sodium is Na with a +1 charge. Hydroxide is OH with a -1 charge. No need to crisscross because they're equal and opposite charges. And it's going to be a double replacement reaction. It's going to form a precipitate of copper 2 hydroxide. So copper 2 and hydroxide. So we crisscross like that. Plus aqueous sodium nitrate. So Na with a +1 charge. Nitrate is NO3 with a -1 charge. Okay, now we're going to go to balance this. So we got 2 hydroxides on this side. We'll put 2 hydroxides on this side. 2 NAs, 2 NAs, 2 nitrates, 2 nitrates, and it's balanced. You don't have to write your solubility rules or whatever. I wouldn't worry about it for this lab. Thanks. 3. You see, I added some boiling chips. So those are little pieces of shale that prevent even boiling. Okay, they don't participate in the reaction at all. So next, I'm gonna go put this on my fire, and I'm gonna heat it up until it comes to a slight boil. Okay, and there will be a distinct change in this rather short. Copper 2 hydroxide, and it's on the Bunsen burner, and we're heating it up. So it'll take a little bit of time to start seeing some sort of change, but there will be a change that occurs. Some sort of change going on the bottom. The appearance of the copper 2 hydroxide. Okay, see, it's going. As it continues to heat up, start seeing this brown solid forming on the bottom. Okay, so we're going to keep going until it's all completely turned brown. As we keep heating this up, more and more copper 2 oxide is going to be formed. I like to call this New Orleans water after Katrina, because that's what it's going to start looking like. So the boiling chips keep this from boiling too hard, and it keeps it from splattering everywhere. So it provides even boiling. Let's go above.
As more and more of the copper 2 oxide is formed, it's going to start looking more and more brackish. Continues to boil. We can see that it's going to be converted to copper 2 oxide as we heat it up. Okay, so we're going to keep going until it's almost to a boil. And so we see more and more of it is being converted. As we near the end of this reaction, we're going to heat it until it just begins to boil. So we're almost to that point right now. The next step is going to be, we're going to let that solid settle, and we're going to decant the supernatant liquid. So we're going to try and keep all the solid that we can, and we're going to pour off the liquid. The next part of the lab says that we need to let our mixture settle. You can see that the solid is collecting at the bottom, and what we're going to be doing is we're going to be pouring off the liquid. Okay, that's called the supernatant liquid. Okay, so I'm going to attempt to do this the best that I can with my camera and my hands and trying to pay attention to what I'm doing. So I'm going to pour off the liquid very, very, very slowly in an effort to try and keep as much of the liquid, as much of the solid in the beaker as I can, because that's going to be our product. And most of that solid is collected at the bottom. So I still have quite a bit of water to pour off. First decanting, we have a little bit of liquid left. So what I'm going to do is the water that I had on boil earlier in the experiment, I'm going to use that, and I'm going to pour a little bit of it into my beaker, and we're going to do another wash. So we're going to repeat this process twice, usually is what I like to do, and we'll pour it off again. Okay? Okay, after watching reaction number 3, we should be able to define these terms right here, precipitate and decant, and we should also be able to note the color of the copper 2 oxide that's formed. If you're not careful when decanting, what can happen to some of the product? Well, you go down the drain. See, what happens when you're doing this on the fly is you mess up when the words aren't worded in the correct order. It says, copper 2 oxide and water are produced when copper 2 hydroxide is decomposed with heat. Okay, so copper 2 is copper with a +2 charge. Hydroxide is OH with a -1 charge, and we're going to have to crisscross. Okay, so when we add the heat, it's going to decompose into copper 2 oxide. Okay, so copper has a +2 charge, and oxygen has a -2 charge, and water, which is H2O. Okay, and then let's make sure it's balanced. 2 H's, 2 H's, 2 O's, 2 O's, 1 copper, and it's balanced. On to reaction number 4, the formation of copper 2 sulfate from copper 2 oxide. The first of the lab is we're going to add 15 milliliters sulfuric acid to our solution. Okay, so let's watch what happens. So we're watching what's happening. This stupid thing keeps beeping. Okay, so not much happened there. It changed all back to that pretty blue, and so we have some copper left on the top. And that's our whole goal, is to recover all of that copper. Okay, I think I've learned my lesson, and I'm gonna read the problem first before I actually try and do the reaction. Okay, so reaction number 4, the preparation of copper 2 sulfate from copper 2 oxide.
What color is the copper 2 sulfate solution that is produced in reaction number 4? You can look at the video, fill that blank in. Okay, it says copper 2 sulfate and water are produced when insoluble copper 2 hydroxide is dissolved by sulfuric acid. Okay, so we're going to take copper 2 oxide. Okay, so copper has a +2 charge and oxygen has a -2 charge. And I'm going to react it with sulfuric acid, which is H2SO4. Okay, and the products are going to be copper 2 sulfate and water. So this is going to be a double replacement reaction. So copper 2 sulfate. Looks like that, no need to crisscross, plus water. And it should be balanced. Okay, so we got 2 H's on this side, 2 H's on this side, 1 sulfate, 1 copper, and so it'll be balanced. The next portion of our lab says we're going to measure out 2 grams of zinc. So I've already tarred the balance and I'm going to sprinkle some zinc. Let's do a little. Okay, so we got 2.04 grams of zinc. That's pretty close. So it'll be good to go for our next portion. So I'm about to add the zinc all at once to the copper solution. And so bubbling quite a bit, and we're going to let it stay under the fume hood until the reaction finishes up. So going on, if you actually touch the beaker like I am, it's very warm. Okay, so it's probably going to be an exothermic reaction. Okay, so the next portion of the lab says that we're going to pour off the liquid. And we're going to try and keep all that solid. See, we're left with this solid right there. Next portion of the lab says we're going to add 5 milliliters of water to our mixture underneath the fume hood. Okay. Swirl around, just make sure we get everything in there. We'll go to the next lab is to measure out 10 milliliters of hydrochloric acid, and we're going to add it to our copper solution. And it's going to drive off any extra zinc that hasn't been reacted. So we're going to leave this in the fume hood for a couple minutes and make sure everything reacts. We're going to warm, but we're not going to boil after we've added the hydrochloric acid to our mixture. Okay, so as my solution, my mixture has warmed up, we're going to measure out the mass of a porcelain evaporating dish. So we're going to use an evaporating dish. Looks like that. You need to record this mass. It's 63.40 grams. So I've transferred my product to the porcelain evaporating dish, and the first wash we're going to do is with about 5 milliliters of water. Okay? So we're going to switch hands. We'll wash our product. And then we're going to pour it off. Wash my product with methanol and acetone, and I've decanted it. So now we're ready to go to the oven. Okay, so let me go show you what the oven looks like. We're going to leave it in the oven for about 15-20 minutes, and then we're going to reweigh it. Now, as we've gone through this process, it's been really hard not to lose a lot of copper because we've gone through 5 or 6 different reactions and we've poured off. So we're looking to get a good % yield on this. So here's our oven. Looks like this. And we're going to leave it in there for about 15-20 minutes. Okay, so after getting our copper out of the oven and fishing out the boiling chips, we're going to say our final measurement of our mass of copper recovered is going to be 63.84 grams. Okay, so we're going to look at the preparation of copper metal from copper 2 sulfate. So this is going to be reaction number 5. Why should most of the steps be performed in the fume hood? The purpose of a fume hood is to suck and to ventilate the harmful fumes that are produced from some of these reactions. If the product is not dried enough, what will happen to the percentage of copper recovered? Well, it could have a false reading and it could weigh more than what was actually recovered. So that's why we put it in the oven for 20 to 30 minutes to make sure it's really, really dry. Why is it important to keep methanol and acetone away from flames? Well, they're flammable. And let's go back to the back page. If all the steps in the series of a chemical reactions in the experiment were performed without any error or loss of material, why should the mass of the copper metal be recovered at the end of the experiment be the same as the mass of the metal of copper metal at the beginning of the experiment? So we talked about the law of conservation of matter and mass at the beginning, so it's probably going to deal with something with that. Okay, so number 5, reaction number 5. It says zinc metal, so zinc is Zn. It's going to react with copper 2 sulfate. Okay, so copper has a +2 charge. Your sulfate has a -2 charge. So this is going to be a single replacement reaction. And it says it's going to form zinc sulfate. Okay. So zinc has a +2 charge. Sulfate has a -2 charge. And it's going to displace the copper metal like that. And it all should be balanced because there's one of each on every side. To find the mass of the copper metal recovered, we're going to take the mass of the bottle or dish in copper metal recovered, data table number 3, and we're going to subtract the mass of the sample, bottle or weighing dish, data table number 2. To find the % copper recovered, we're going to take data table number 4, the mass of the copper metal recovered, and we're going to divide it by the mass of the original copper sample, data table number 1. Don't forget that when you convert to a percentage, you multiply by 100.